got a little starter on your yes, Ken problems. I'm not sure. Have you all come across a Ken before? No. Okay. You're probably looking at it thinking this is like Sudoku. It's not maths. There is a maths element in these Ken problems. Ken is the Japanese word for wisdom. So there's a problem-solving element and a calculating element to these Ken problems. They're based on the Latin square. So in each row and in each column, the digits can only appear once. And the two that you've got in front of you, they're 4 by 4 squares. So only the digits 1 to 4 can appear in each row and each column. You can see that there's bolded boxes or cages with a number and an operation written in the corner. The number is your target. The operation is what the operation should be done to those numbers. So if you look at the Ken you've got on the right, we were going to go through this on the PowerPoint, but never mind. The one on the right of your sheet, you can see that there's 2 cages already where there's no operation. The 3 and the 4, the one on the right-hand side of the sheet. Okay, that's easy. That's your starting point. This is an easy Ken. Okay, so you put the 4 in the 4 box and the 3 in the 3 box. Okay, see some people doing that. All right, so if you're not sure what to do next, you need to start to look at the other cages that you've got going on in front of you. Has anyone got any ideas what you might be able to fill out next?
I think
the multiply by 6 cage, because there's 2 factors of 6 which are in the range 1 to 4. They are 3 and 2. And again, you've got a 3 in the cage next door to one of those boxes. So you can't put the 3 in that row. It would have to go in the bottom row. And the 2 will have to go to the left of the 3. It's not very easy.
Again?
I'm sorry, wasn't it? All right. So you've got your 3 and your 4 filled in.
Yeah.
This page, we know that the factors of 6 are 3 and 2. You cannot place the 3 in this box because you've already got a 3 in the adjacent box. Okay, and the digits can only appear once in each row. So therefore the 2 has to be placed here and the 3 in the box below. Okay? So once you've filled that, can I hang on to this a sec? I'll give it back to you after. Once you've got that filled in, you can look around the problem. What can you fill in next? Are there any next steps anyone can see?
7 plus.
The 7. That might have been your second step actually. You could have done that one or equally. The 7 plus 2 digits, that's 3 and 4. Okay, so you can work out which box you're allowed to put the 4 in. It can't go adjacent to the 4 already. It's got to go in the one below, and the 3 in the one above. Okay, and the 4 will go below. So now you've got a row in which you've got 3 items in the row. You're missing a 1 in that row. You can put 1 in there, and you carry on like that. Have I got everyone with me? Yeah. Okay. Quite a nice little starter activity, which involves number skills as well as logical thinking. I put at the bottom there a website. I registered with this website.
When we were asked to present this, we really felt between the 3 of us there were 3 key themes that we thought you'd benefit from the most. Hopefully we'll be starting with, just to give you a little introduction into what we feel is important in problem solving, how we feel students, what they respond to from our experience, what they've gone through, and kind of the steps that they break it down into. Ways in which in classes you can give them a task which might be something like this, 5 minutes, very quick, very simple to get started on. It could be something that lasts a lesson long. It could be something that you extend over a period of a week. So what we want to do is kind of really start by highlighting what we feel makes a good investigation, what makes a good activity in a task to start though developing those problem solving skills. Then we thought we'd actually give you the opportunity to look at some of the tasks that we do with our students. So what is it that we do, how do we approach it, and how do we instill those skills really, and how do we develop them as they move through the key stages. So we'll be giving you the opportunity to look at some of the tasks, and Roxy will be doing some of those tasks with you so you can break it down. And I think the key element there will be, hopefully what we're hoping is that if you are given the opportunity to look at the task while we're here, you'll be more inclined to use it when you leave this room today. We're going to be giving you ready-made resources that we use as part of our everyday practice. So what we really hope to do is to give you the opportunity to not only do them, but scrutinise them, tell us what you think. And if you've got any questions on them, please ask us. There will be a question and answer session at the end of this, but as we go through the tasks, if there is anything that comes up that you're not sure on, or if there's anything that you feel is not relevant to yours and how we could develop that, then please feel free to stop us and ask us. Everything that you see from, now the presentation's up, okay, everything you see from the presentation to these resources and any other tasks that are going to be coming up your way, they will all be made available on the Dropbox, so please don't feel that you have to write everything down and you have to get hard copies of everything. The key thing for us is that every single person in here works in a different sort of school, and the resources that we use in ours might not be necessarily translatable straight to your school. What we're hoping is that you leave here with some resources that are kind of in electronic versions, but that we give you, hopefully we can pass off some of those skills to you that you can then understand how to develop and how to change things to make it more applicable in the faculties that you work in and in the school, the students that you have in front of you. Roxy's going to start with, we've just seen a quick 5-minute starter, but of course the problem solving skills that come out of the 5-minute starter is, they're very limited. What we're hoping is that as you do longer investigations, you have the time with your students to actually bring out more of those skills. So Roxy's going to be introducing you to a slightly longer task, giving you the opportunity to do them, but please ask us questions as we go through it, if you have any.
You should have a copy of this on the back of the paper. Some of you, I think, have a similar side of it. We have sheets here. This is a resource that I accessed on the internet, and it was called Staircases, and I wanted to do some investigation work with my Key Stage 3 classes. And the first time I actually found the resource, I used it exactly as it was and didn't change it. But after teaching the kids, I realised there were certain changes that I would have made had I looked at it in a bit more detail. And so what I've done is, this kind of investigation, I used it in the classroom and we spent about 4 lessons on it. It can be shortened and it can be lengthened. It all depends on how much time you have and the ability of the kids that you have in front of you. So here's the problem. It's called Growing Staircases, and basically, sorry, you basically what I've done here is created a booklet which you will have access to at the end. I haven't photocopied one for everyone, but there are some floating about that you can have a look at the end. And the way that I would tackle this investigation task with my lower end ability kids in particular is to lead them through it. So that we've got an example here of a staircase. Cubes are used to go a staircase. Investigate the number of cubes that are needed to create a staircase of any given height. Okay, you can see height 1, we use 1 cube, height 2 is 3, and so on. So the kids are given this problem, and usually I encourage them to work in pairs so that they can create a bit of discussion, chat about what they see, what they think the solution is. So what I would like you to do is, even in your rows, if you can take a couple of minutes looking at that problem, and while you're actually discussing the problem, I would like you to focus on writing down the strategies that you've actually used to come up with a solution. Alright, so we'll give you another couple of minutes in your group, introduce yourselves to each other. I know we don't have groups, but if even in your person next to you, or if you could just have a couple of minutes to discuss the problem, how would you solve this problem? And the goal is to try and find out how many cubes you're going to need for a staircase of height h.
2x minus 1?
Sorry?
2x minus 1?
Yeah, I mean, I think the thing is, it's not really the answer that we're worried about, it's kind of the approach that you would take and how you would break it down.
Right. Now, what I would like you to focus and maybe jot down is the skills. What strategies are you using, or what would you be looking from your kids? That's the thing that we find when you're teaching problem solving, giving them kids a question.
Okay, guys, if I could just have your attention again, please. What we were hoping that would come out of doing this task is, you know, of course we can all do the problem, we all know the answers, we're all mathematicians, but the key thing about this sort of a task, this investigation, is not necessarily to come up with the answer. It could be something that you even give the students the answer to. The answer to this question is this. But how would we break it down and how do we get to the final answer? How would we explain what we've done? How would we, in maths terms, write down and explain what we've done? How would we do it diagrammatically? For us, we think that these are probably the key elements that you need to break a problem down to be able to solve them. We're not saying that this is it. This is not exhaustive. There are other elements that are important, but these we feel are the key issues that students need to really address when doing it. Again, this is all on the Dropbox, so please don't feel that you need to take pictures and stuff of it because it is all there available for you to take. We've even got ones like that where each task has been put onto an A4 sheet of paper. These are the sorts of things that we would hope that when you're giving a task to a student to do, you're breaking it down into these elements and highlighting to them that first thing you want to do is break down the steps. You want to break down the task. It doesn't have to be in that order. It could be in any order. You first might want to look at the problem and say what is important, what isn't important. Let's separate the two first. You might want to say to them, let's just start doing some rough workings out first. Okay? It doesn't matter which order you do these in, but highlighting to them that they are doing this and they are doing that and they're drawing pictures. All these sorts of key processes that they're doing, you've got to choose what the right operation is, choose what the right methodology is behind it. All these sorts of things, using these logical reasoning, how they do it and the order in which they do it doesn't matter necessarily. That will depend on the task in which you've given them. But what we think is that the experience that we've got is that students often have these skills. They often know that they need to break it down. They just don't know necessarily how to articulate it. They don't know how to put it down on paper. They don't know how to create a lengthy investigation. If it's a week-long investigation, they might not know that, oh, first I had a look at the problem, I broke it down. Then I got rid of the bits that I didn't really want to, that wasn't going to actually affect my final answer or input into my solution at the start. The way that they break it down, it might just be a big jumble in their head. They need structure to actually understand how to break that task down. And these are the kind of the things that we think are important. And I think the two, and although they're written really small, make mistakes. So many students think that they're not allowed to make mistakes when they do these investigations and this work. They think they've got to get to the answer straight away. They don't realise that, oh, where's the working out to get to that formula that you got? Oh, miss, I threw it in the bin. Well, why did you throw it in the bin? That's part of your problem-solving process. Don't throw that work in the bin, keep it, and use it to understand how you develop from that idea. And don't get frustrated. So many of them get frustrated, especially at the higher end. You give them a task and they can't do it straight away. And the students will say, I'm getting frustrated, I can't do it, and they lose focus. So, tell them it's all right to get frustrated and it's all right to make mistakes. Don't disregard it, keep it as part of your documentation of how you're getting from one stage to the next. Really, this task can be, Roxy's done it in a lesson and she's extended it and done it over a week. And what we're going to be focusing on next is kind of what elements that you need to think about to make a task that is going to be suitable for just one lesson period and it's done, or what sort of things you need to consider if you're going to stretch it over a week. Do you want to do the next bit then?
I'm just going to give you, we have this as an exemplar, unfortunately, because of our ICT issues, I might not be able to bring it up on the board, but this is basically what I gave my students. For a lower end ability group, I started off and I just gave them that problem plus a bunch of cubes. And the initial task was just to have a play around with the cubes and build the staircases. So that was step one, just to get the feel of how does this pattern grow. And then after that, I had them actually draw on isometric paper what the next two would look like. So this is one of the kids' piece of work. So you can see they've actually had a chance to play with the cubes and then they've actually drawn them out. So after a bit of time on that, I've introduced what the problem is. Okay, so to build a staircase of height 5, how many cubes am I going to need? Of 6, how many am I going to need? And what I said to the kids was exactly the same problem that I presented to you. Well, how am I going to find out how many cubes I need for height of h? And I left the kids to it, and what I found a lot of them did was randomly, one of them was making a staircase of height 10. The other one was making a staircase of height 3. Another one in the group was 2. So there was no kind of strategy in the place. They just wanted to build these cubes. And they weren't really thinking as a group, well, what would be the first step? They were just having a play around. After bringing them back, I felt that, especially as a start-off task with year 7s and 8s, I really led them through the investigation. I'd let them go away, build the staircases, and then I'd bring them back as a class, and then I'd ask them questions. I'm going to, because they mentioned, oh, you need to be looking for a pattern. How am I going to find that pattern? So I had to highlight to them that it was important that they found the height for 1, 2, 3, 4, and so on. And that was something that is considered one of the problem-solving strategies, because the kids, to them, I said, well, okay, in that case, to see a pattern, especially for a lower-end group, I would then say, okay, well, how are we going to record what we found? And the kids have been able to give me the details that I've wanted, but I've had to really lead them through it. So put your information into a table, okay? So in that booklet, on the next page, I gave them the table, okay, with the heights, and then they had to write down how many cubes. They were able to write down how many cubes were needed for each of the heights, and then gave them those 2 questions as well, okay, leaving blanks, giving them a bit more time to say, right, okay, I'm going to leave you for 5 minutes. I want you to try and tell me, well, there's something obviously happening. They've already mentioned the word patterns. So what is the pattern? And then once the kids have had a chance to actually discuss it in their groups, they're actually starting to say the right things. You know, they're talking about tables, they're looking for patterns, they're trying to they're thinking the numbers are going up, or the numbers are going up by 2 each time. So they're actually giving them a chance to try it on their own, but actually keeping the class together, especially for a task. First time I've introduced problem solving to the lower end kids, because if you leave them with a problem, they really don't know how to put their solutions down on paper, and it's to guide them through the process and highlight what they should and shouldn't be doing. So they've been able to come up with, you're adding on 2, and for this next section, how many cubes are needed for a height of 10, a lot of them have gone away and built a height of 10 or 19. But then I've said, okay, well, what about 100? Are you going to build a staircase that has got a height of 100? That's going to take you forever. And then they start talking about, okay, we're looking for a formula that's going to work every single time, irrespective of how high our staircase is. So I found that with lower end kids, you really need to, like even with this student here, she's come up with the rule, and to extend this investigation, and I want to push and challenge these kids to think for themselves. For a higher end ability group, I would then maybe consider saying, okay, you've come up with the rule, C equals 2h minus 1. Where does that come from? I want you to explain that rule to me in terms of, show me it with the cubes. I've given them the cubes and said, well, explain to me, where does the 2h come from and where does the minus 1 come from? Why does that happen? If you were explaining this solution to somebody that has no idea of maths, how would you put that into them in words? Where does 2h minus 1 come from? And so to extend it, that's something that I would ask the kids to do, and I've actually added that to the booklet. Write in algebra the rule, and can you explain why the rule works? And I've given them a hint, use diagrams to explain your answer. And this student has gone away and done exactly that. She's shown me that you double the height and then 1 cube has been subtracted. So she actually used the cubes to explain the formula. And then she's actually written down her explanation in words as well. You know, because the one thing I find is that kids are great to give you an answer, but to actually lead you through the process, they're probably not even aware of the steps that they're actually using, and it's very important for us to highlight to them, you know, why are you putting things into a table? What are you looking for? How do you break the problem down? How do you make it simpler? And that's, I found really, really helpful. And then to extend the task even more, if I was to maybe do this with a year 9 top set or even year 8 top set, I could then, that's just the explanation, say, okay, the design has changed now. The second example there basically leads to a formula which is a quadratic. Okay, the third staircase leads to a formula which has got fractions in it. So to make the problem more difficult, you can make it as simple and extend it as much as you want. And again, with that group, this was done with a year 8 group. She's actually gone ahead and drawn her. She's actually drawn her shapes on isometric paper, but I gave them the tables and I led them through it. The next time I do an investigation task, I may not go to that much detail with that particular class because I've talked them through one and they know what to expect then. They know what I'm looking for. And I try and encourage them to write things in their own words because otherwise, how else are they going to learn to explain what's going on in their mind? Start with a bit of an introduction. Maybe the next time I would do that task, I would say, right, I want you to write an introduction for this task. What's the actual problem? Because a lot of kids don't understand what the problem is asking them, but they jump into trying to solve it.
And I think the other thing about this is that it's not necessarily the maths, the curriculum. I think we get so bogged down with teaching them the curriculum, and we're obviously under so much time pressure to get through things for exams and everything else, but skills that we're teaching them here, they're not math skills necessarily. You can extend the problem. We could have given that third design to maybe like a high ability year 11, but just because they're really good mathematicians in year 11, it doesn't mean that they're going to be excellent problem solvers and that they can break down these steps. So the level of maths that we're introducing, that can vary depending on the students that you have in front of you. But the way in which you break the task down, whether it's a table and a table format and guiding them through it, holding their hand, or whether it's just eliminating parts of those tables and those sorts of things, the way in which we approach that, that's the key focus. So it's not necessarily that we're going to be able to grade that and say that's an A grade piece of work, or that's a level 7 piece of work there. The problem solving skills, it's kind of just, it's more kind of the peripheral, you know, that the other things that they need to be doing to become good problem solvers outside of the classroom. And that's kind of where we hope that they'll apply this.
Sorry, I'm just going to speak to you very quickly. Last thing I wanted to mention, I've not brought it up, we've not got a slide showing this, but then this is the same problem that extended, where if I gave the kids, you can extend the problem even further and say, okay, you're climbing these stairs now. You can either climb taking one step at a time, or you can climb 2 steps together. So how many different ways are there of climbing a staircase with 5 steps high? So she's gone away and investigated that, and the way that I would normally grade the kids, I would, you know, obviously leading them through, trying to encourage them. This one's been kind of marked along the way, but I would normally just give them pointers. They've actually, rather than give them a final grade, I'd give them pointers. Go and do this. This is what I think. If you were to do this again, this is the things that you've missed out, and gave them a 1, 2, or 3. So they're not actually getting. I don't have a criteria that I would use, but it's more so the kids have actually said to me they've gained a lot. And with this particular group, it was one of the first investigation tasks that we did this year, and I wanted to get feedback from the kids. What did they gain from it? What did they learn? Did they enjoy it? Did they not? And I said to them, right, if I were to ask you, why should I give you another investigation task? Because they all really enjoyed it. They said they wanted to do it again. I said, but why? Why should I give you another task to do? And I said, tell me the things that you've learned. So I made them write down in a circle the skills that I have learned through investigation: drawing with isometric paper, learning to summarise, best way to work out a pattern, triangular numbers, how to solve a problem, looking for pattern, organising my results, putting my results in table, finding general rules, and being systematic. To me, that was an achievement that the kids are actually now aware of the things, you know, the processes that they're actually, and able to talk about them. You know.
Well, what I've done in the past as well is, if you highlight the key skills you want them to look at, you can put them in a table. I should have brought an example actually. I've just thought of it now. But the all the different skills that you put in it could be an Excel spreadsheet, it could be a Word, just a table. But the different skills that you expect them to be looking at over the period of the task, and they literally just highlight it from I'm not very good at this to I'm okay but I need more improvement to I'm brilliant, and they themselves self-assess. So you can get them to do it at the start of the investigation, assess where they're at, colour in the blocks where you think they are, and then at the end of the investigation, whether it's a 1 lesson period or whether it's a week-long investigation, now highlight and see where you've done it, and at intervals through the week even, highlight and see where you're developing. What have you developed this week? What do you still need to focus on? are you still able to break down a problem, or do you need to now develop on how to draw, how to put my explanations down on paper? They can assess that themselves, and you know, just a simple grid is great for them to just kind of get, and it gives you a good idea of kind of the progress that they've made as well, and it's very little effort. I think it's the easiest bit. But
going back to this booklet, this is in the Dropbox, and when you actually look at the booklet, there's quite a lot of blurb before the investigation starts. Now, I'm just going to very quickly talk to you about the pages. The first one is basically just objectives, what the kids should gain after doing the investigation. And I usually talk to them about these, and these are also on the PowerPoint slide, so you could bring this up in the classroom if you were to use it. See the problem, understand the problem, then talking them through a plan. You're not just going to jump in. What's your plan? Deciding on a method, how you're going to get to the solution. And then I actually get them to fill out what their plan is. All right, this is what in their eyes or words, I want you to put down. How are you going to tackle this problem, and what is your plan? To make them aware again of all of these strategies and skills that they actually have, give them, you know, this diagram, the maths problem solving toolbox, and in there they can act it out, they can guess and check, they can looking for patterns, making the problem simpler for themselves. Have they seen another problem that's similar? You know, just making them aware that, you know, these are all strategies that you're using to solve that problem. And then also mentioning other strategies that they might not be aware of. Guess and check, trial and error, gathering data, drawing diagrams, working backwards. These are all strategies our kids are not probably aware that these are actual, you know, things that they can do and they can write and talk about. Then there's a do, carry out the investigation, and what mathematical processes are you using? You know, mentioning the words questioning, generalizing, exploring, hypothesizing, reflecting, predicting, justifying, exploring, experimenting, and then there's a final check and reflections page. So I have these all these 5-6 slides on the PowerPoint. So as I'm leading them through the investigation, I would refer to these and mention these words. The kids, they'll get this booklet and they'll fill out. And there is copies for you guys to take away with the teacher solutions as well. This resource was found on the internet. There are millions and millions and millions of similar resources, and there's one particular website that I'll show you at the end that I found very useful for investigation work.
I think for us, when we were talking about problem solving, it wasn't just what can we do in the classroom to help them problem solve. It was kind of what can they do outside the classroom as well. So rather than just focusing on the 5-minute starter like Penny showed you at the start, or whether it's an investigation that's teacher-led, it's kind of what else can they do? When they're outside that room, how are they going to put those problems, how are they going to break down a problem and be able to solve it themselves? Penny's going to talk to you a little bit about kind of how you can manage that and kind of ideas that we have that we use as part of our everyday practice. Do you want to take
Is it on the next slide? Yeah. Okay, so I thought I would talk to you about setting up a problem of the week, something that you might be able to do in your school. So I'm going to talk a little bit about the management of something like that, and then I'll show you a very good website that I use to get resources for this type of thing. It's already set up with problems of the week available. Solutions for the current problem of the week aren't available on the internet. So as long as you're sort of keeping up to date with this